Host/instance CPU. The CPU utilization percentages are essential for assessing how the CPU resources are being utilized in the system. Look at the host CPU and instance CPU sections. In these sections, give attention to the value of % idle in the host CPU section and % total CPU in the instance CPU section. If the % idle is low and % total CPU is high, then the instance could have a bottleneck in CPU. % user value indicates that the CPU time is actively executing user processes. % system values indicates that the CPU time is handling system-level activities. % WIO values indicate that the CPU time is frequently waiting for I/O operations to be performed and can be assigned by /O bound processes. % idle value means that the CPU time is mostly idle and not fully utilized. Instance CPU is basically CPU used by Oracle instance. % total CPU usage but Oracle. % busy CPU, total actual CPU busyness on the server. % DB time waiting for CPU resource manager. This metric represents the percentage of database time spent waiting for CPU resources to become available. First report shows that the server reports 24% CPU usage, but Oracle used only 2.4% of the total CPU available. This also translates about 9% of the total actual CPU busyness on the server. Second report shows % user plus % system, 7.5 plus 0.8 equals 8.3. 100% idle, 100-91.3 equals 8.7. Both the above results are a close match. 100* total instance CPU / total host PU, 100* 7.5 / 8.7 equals 86.2, which matches with busy CPU % as shown in the report. Third report shows the value of % idle is 0. There remain no free CPU cycles. Another means of determining whether or not CPU capacity is lacking is to compare the number of cores against the current demand on CPU per second. For example, assume that the number of cores, not CPUs, at the top of the AWR report is equal to 12. In this situation, the most CPU throughput the server can produce is 12.0 seconds per second. Let's compare that to the current demand for CPU utilization, as listed under the load profile section. Since 22.6 is far greater than 12, this is a capacity planning issue. In fact, the per second demand of 22.6 is probably understated, given the fact that each session is unable to obtain core CPU instruction cycles when it needs them. Instead, it waits on a CPU run queue of ready-to-run processes, each of which is waiting for an available core. Therefore, additional, unnecessary delay is introduced when a session is trying to time exactly how much CPU it has consumed, because it requires a core to be free immediately in order to record the ending time of the quantum of CPU which it's measuring. Waiting in the run queue for a core will make the elapsed time even larger. If you are running Oracle database on either Unix or Linux, then also consider executing vmstat during a time of peak workload. The R column in its output will show you the length of this run queue. Any count of processes greater than the number of physical cores is the number of database sessions sitting in the CPU run queue. I/O profile section provides high-level database I/O activity. This section gives an overview of how much I/O is being driven by your database in terms of physical reads and writes, redo and more. Total requests in the AWR report typically refers to the total number of requests or calls made to the database during the specified time interval covered by the report. It gives you an idea of how busy the database was and how many operations it had to process. Database requests, the number of times the database was actively doing something on behalf of user sessions or applications during the AWR snapshot interval. It includes all kinds of activities that the database performs, such as executing SQL statements, processing transactions, handling user connections, and managing background tasks. Optimized requests, optimized read requests are read requests that are satisfied from the Smart Flash cache, or the Smart Flash cache in Oracle Exadata. Optimized IOs on Exadata include IOs on Smart Flash cache, IOs from SmartScans, including IOs saved by storage index, and IOs saved by columnar cache. Redo requests provides information about the generation and usage of redo logs in the database. Database blocks. This represents the number of Oracle database blocks read from and written to storage during the specified time interval. The buffer cache blocks section helps you understand how efficiently the database is utilizing the buffer cache to satisfy read requests. Ideally, you want a high percentage of data blocks to be accessed via the buffer cache, consistent gets, rather than fetching them from disk, physical reads. Direct blocks. This section represents information related to direct path reads and writes. Direct path reads. When a query requires data that is not in the buffer cache, Oracle can read the data directly from the data files into the process PGA instead of first placing it in the buffer cache. This is known as direct path reads. Direct reads can be faster than normal buffered reads, especially for large data scans, but they can consume more CPU resources. Direct path writes. When data needs to be written to the database and it is not buffered in the SGA system global area, Oracle can write the data directly from the PGA to the data files. This is known as direct path writes. Like direct reads, direct writes can be beneficial for bulk data operations, but they can also be more CPU intensive. Memory statistics. The memory statistics section compares PGA and SGA memory statistics between the two snapshot sets. Includes information about the memory usage of the Oracle instance. This might include details about memory allocated to the shared pool, buffer cache, and other memory structures. Based on load, database server keeps on allocating or deallocating memory assigned to different components of SGA and PGA. Due to this reason, we can observe different sizes for buffer cache and shared pool at the beginning or end of AWR snapshot period. Buffer cache. The buffer cache holds data blocks read from data files, serving as a cache for frequently accessed data. This cache helps reduce disk I/O and improves performance by keeping frequently used data in memory. The buffer cache size is shown in bytes. Shared pool. The shared pool is a critical area in Oracle's System Global Area, SGA, that stores shared SQL and PL/SQL areas, as well as other shared memory structures like dictionary cache, library cache, etc. Extremely high % usage of shared pool indicates a need for increasing the shared pool size, while a very low utilization indicates a larger than required pool size for the given workload. Shared pool statistics. Memory usage %, 91.53 means that 91.53% of the shared pool memory was used, which is within a reasonable range. %SQL with executions 1, 93.02 tells us that 93.02% of the SQL statements were executed more than once, indicating a substantial workload with repeated queries. Memory for SQL with exec1, 92.53 means that 92.53% of the shared pool memory was used to store SQL statements with executions greater than 1. The time model statistics section provides detailed information about the database's resource usage and the time spent on various activities during the analyzed period. This section provides a summary of components where the database is spending its time. The table contains system resource consumption metrics, which can be ordered by time, S, and % of DB time. One has to look for the statistic taking maximum % of DB time and compare it with baseline for any abnormal behavior. If SQL time DB CPU time, then the system needs to be diagnosed for I/O issues. Statistic name. This column lists the specific activities or resources for which the time statistics are reported. Examples include DB time, SQL execution elapsed time, CPU time, I/O time, and many others. Time, S. This column displays the total amount of time, in seconds, spent on each activity or resource during the analyzed period. It represents the cumulative time spent across all sessions and processes. % of DB time. This column displays the percentage of the total database time spent on each activity or resource relative to the total database time. It helps in comparing the impact of different activities on overall performance. % total CPU time. This column shows the percentage of the time that was consumed on CPU resource. SQL execute elapsed time, time spent executing the SQL statement. DB CPU represents time spent on CPU resource by foreground user processes. Parse time elapsed. This elapsed represents time spent for syntax and semantic checks. Hard parse elapsed time of this represents time spent for syntax and semantic and time spent for optimizing the SQL and generating optimizer plan. OS Statistics section provide insights into the operating system's performance, resource utilization, and configuration. It provides information about the system-level performance metrics related to the server's operating system. Free_memory_bytes, the amount of free physical memory, RAM, in bytes available on the system. This is memory that is not currently in use by any processes or the operating system. Inactive_memory_bytes, the amount of memory in bytes allocated to processes or applications but not actively in use. It represents memory that is loaded into RAM but not currently needed by running processes. Swap_free_bytes, the amount of free swap space in bytes. Swap space is used as a complement to physical memory, RAM, when the system needs more memory for active processes. A high value suggests that there's ample swap space available. Busy_time, the total time, in seconds, during the AWR snapshot interval that the CPUs were actively executing tasks. It reflects the amount of time the CPUs spent processing user and system tasks. Idle_time, the amount of time, in seconds, that the CPUs remain idle during the snapshot interval. It indicates periods of low CPU utilization. IOWait_time, the time, in seconds, the CPU spent waiting for I/O operations to complete. This includes periods when the CPUs were idle due to waiting for data to be read from or written to storage devices. Nice_time, the time, in seconds, spent executing processes with a nice priority. Processes with a nice priority have lower scheduling priority, and this metric reflects the CPU time spent on these processes. Sys_time, the time, in seconds, spent on system-level tasks, often related to operating system functions, kernel-level operations, and system administration. User_time, the time, in seconds, spent executing user-level processes, including application and user-initiated tasks. Load, the load metric indicates the system load averages for the 1-minute, 5-minute, and 15-minute periods before the snapshot was taken. High load averages suggest that the system is under heavy demand. VM_in_bytes and VM_out_bytes, these metrics represent the amount of data, in bytes, read from and written to virtual memory, paging, during the snapshot interval. High values indicate significant virtual memory activity. Physical_memory_bytes, the total amount of physical memory, RAM, available on the system in bytes. NUM_SPUS, the total number of CPU threads or logical processors available on the system. NUM_CPU_cores, the number of physical CPU cores on the system, providing insight into the physical CPU architecture. NUM_CPU_sockets, indicates the number of physical CPU sockets on the system, relevant in multi-socket configurations. Global_receive_size_max and global_send_size_max, these metrics specify the maximum size, in bytes, for global, interprocess, data transfer operations. TCP_receive_size_default, TCP_receive_size_max, and TCP_receive_size_min, these metrics specify the default, maximum, and minimum receive buffer sizes, in bytes, for TCP connections. TCP_send_size_default, TCP_send_size_max, and TCP_send_size_min, these metrics specify the default, maximum, and minimum send buffer sizes, in bytes, for TCP connections. OS details lists the CPU utilization breakup across system, user, busy, IOWait and idle along with load statistics.